In the last video tutorial, we have learned how to find the area of a regular plane with irregular curves on the side. And it is bounded by the x or the y axis. So what if the curve or the plane is now enclosed by two curves with irregular curves or irregular shapes? In this tutorial, or in this iteration of problem solve, we're going to learn how to solve those kinds of figure and it's called area between two curves. Okay, on our last video tutorial, recalling our previous topic, so we have here a figure like this, so something like this, so we have here a Cartesian plane, and then we have your regular curves. If you want to recall this lecture, and then we need to find the area under this certain section, and we strip that into several strips. So strip 1, strip 2, if you can still recall that. And we simply use the upper bound, and the lower curve. And we say that the area is equal to the integral of the upper function y minus the lower function of y, which is of x, running from certain limit a to b. So that will be running from a to b, deriving with respect to x. So what if now, if we have an irregular solid or irregular plane figure bounded by two curves, such that it looks like this, for example. So we have here a curve that's something like this, and we have, for example, a parabola that is something like this. So how do you find the area? So we still strip this, so we're finding the area here. But actually, we can still solve this by the means of stripping, just like what we did in our previous lesson, and it's still applicable here. So we have here limit a, limit b, and we're going to use the same formula, which is this. The only difference is that we should be familiarized, or we should be aware of the points of intersection where the 2 points will meet. Such for this case, we have here a point here. So this will be our x2 and y2. Since this will be the first limit only bounded by this would be our first limit, which is equal to at x is, so that will be x1 and y1. So that point, or that would be the running values. So that will be our iteration for this tutorial. So we're going to solve the area bounded by the two curves. So let me erase this first. Okay, now everything is erased. Okay, now everything is erased. So I'm going to write now the example problem. So let's write here this example problem. Find the area bounded by the curves y squared is equals to 4x and x squared is equals to 4y. Okay. So we're now going to solve this. Okay. So we're given two curves, y squared is equals to 4x and x squared is equals to 4y. So inspecting the curves, certainly that would be two parabolas. So I'm going to have here another Cartesian plane. Then we know that y squared is equals to 4x is a parabola vertex at 0, 0, opening here. So it's not that perfect, I'm sorry for that. So if I'm overextending that, so it might overlap my board. Okay. And x squared is equals to 4y is a parabola with vertex 0, 0 that opens upwards. So that would be something like this. Okay. The only problem that arises here, okay, since we're going to find the area by using a strip, okay, as you can see, it is necessary if you're going to use a vertical strip. Though we can also use a horizontal strip, but I find it more convenient if we're going to use the horizontal elements. Okay, so we know that this point is 0, 0, where one intersection of the curve is located. So this would be 0 and 0, okay. So that would be one limit. But we need to find also this point of intersection. So how do we find that? So to find the point of intersection here, we can use these two equations and find for a critical value wherein the two will intersect. How? Okay. So let's manipulate the equation and find for the possible values or find the values for this point. We have here y squared is equals to 4x, right? Okay. We can manipulate this equation so that I'll have here y is equals to square root of 4x or simply is equals to 2 square root of x. Let us call this as our first equation. We have here another equation, x is equals to 4y, okay? But as you can see, we have transformed equation y to y, okay? So we're going to transpose 4 and let's also equate this to y, okay? So that x squared over 4 is equals to y, okay? And this would be our second equation. So equating these two equations, okay? So equating this with this leads to a single line equation, which is x squared over 4 is equals to 2 square root of x. We only need to find x, okay, here. So how do you find x from here? So from here, we can raise both sides to its square so that I can eliminate the radical. So raising both sides to square, okay, we'll have x raised to 4 over 4 squared, okay, is equal to 2 squared times x. Okay. So manipulating this equation, okay, so we're going to have x raised to 4 over x, putting it here, is equals to 2 squared times 4 squared. Okay. So x and x raised to 4, okay, we can cancel that out. What remains is x cubed. So x cubed is equals to, so 2 squared times 4 squared. We can further reduce this to 2's. So we have here 2 squared times 2 squared times 2. Okay. So we have here x cubed is equals to 2. Okay. And then we have here 2 times, this would be rather plus 2 plus 4. Okay. By law of exponent. So we have here x cubed is equals to 2 raised to 6. Okay. So in order for us to retain only single x here, we need to find the cube root of both sides by raising both sides to 1/3. So that will have x is equal to 2 raised to 6 over 3, or simply x is equals to 2 raised to squared or equal to 4. Now we have the value for our x. How about the value for our y? So we can use this value and substitute it to which of the following or either of these two equations is more convenient. For this case, I think the more convenient equation would be equation 1. Okay. So substituting this to equation 1, okay. Substituting the equation 1, so we'll have here y is equals to 2, then the square root of value of our x is equals to 4. So that we'll have y is equals to 2, square root of 4 is simply equal to 2 times 2, so that the value of our y is equals to 4. Now we have the ordered pairs for this, which is the coordinate of 4 and 4. Now we can solve for the area. Okay. Okay, I erase this. Okay, now that we find the coordinates 4 and 4, okay, we can now decide if we're going to use a horizontal strip that looks like this, or a vertical strip that looks like this. But remember, if you're going to use horizontal strip, we're going to use, or we're going to integrate with respect to y. For this case, we're going to use the vertical element. Okay. So that the area, as we can recall, this is simply the integral of the upper y, okay, and the lower y, which is our g sub x. Okay. So we'll have here y upper minus y lower. Since this is y, okay, equal to x, so this will be our dx. Running for the values of our x, so that would be running from 0 up to 4. Then we can now integrate. So that would be integral running from 0 to 4. Our upper y would then be this curve, which is y squared minus 4x, or simply that is equal to 2 square root of x, okay, minus our y lower, which is the parabola that opens upward. Okay. So y upper is, so we can transform this, okay? So the transformation will be x squared over 4, okay, 6 goes to y. And that would be x squared over 4 dx. Okay, now we can distribute integration by here. So we have your limit from 0 to 4, or running from 0 to 4, 2 square root of x dx minus, okay, integral running from 0 to 4, x squared over 4 dx. Isolate the constants. So we have here 2 integral of running from 0 to 4 square root of x dx minus, isolating 1/4, integral running from 0 to 4 x squared dx. Integrating this, actually we can transform this to x raised to 1/2. Okay, let me use another color of marker here. So x raised to 1/2. Okay, since that is curved. Okay. And now, so by power rule, that will be plus 1. Okay, so that would be 2. Okay, so x raised to 1/2 plus 1, so that would be 3 halves, x raised to 3 halves, over 3 halves. Okay. Minus 1/4 integral of this, so plus 1 over 2 plus 1, so that would be equal to x raised to cube over 3. Okay. Running from 0 to 4. Okay. Now let's try to simplify this, so this becomes 4. Okay. 4x 3 halves over 3 minus x cubed multiplied by or divided by 12, running from 0 to 4. So evaluating the integral, okay, running from 0 to 4, okay, so that would be by using definite integral for this one, so that would be 4. Okay, we have here x raised to 3 halves, so that would be 4 raised to 3 halves over 3 minus, okay, so 4 raised to cube over 12. Okay. Oops, yes, 12 1tt minus, since everything will be multiplied by 0, so that is simply equal to 0. Okay, so we have here 4, so 4 raised to 3 halves, so 4 over 3 times 4 raised to 3 halves. So we have here 4 and 1/2, 4. So we have here another 4, then 2. Okay. Minus, okay, 4 raised to cube over 12. Okay. And then simplifying this would lead us to the answer, which is equal to, okay, sorry, so 5.33 per units. And that will be the answer for this problem. Problem solved. So do you have any questions regarding this problem? Do you have any clarifications? If you have some, don't hesitate to send me a private message.